Hello Math 1 students, this is Mr. Flynn. We're going to be going over distance formula and midpoint formula again to see it in a few different lights to see how it works. Alright, so let's just keep an eye on this. We do have a test this Friday, and this will be for April 3rd or 13th. Okay, so the distance formula, if we remember, the distance between 2 points is equal to the square root, that long square root. And remember, you can use your formulas. We have x of the second point minus x of the first point, quantity squared, plus y of the second point minus y of the first point, quantity squared. Okay? What they're doing in problem number 1 is they're using the Pythagorean theorem. We've talked about this a little bit. If you remember, the Pythagorean theorem says a squared plus b squared equals c squared, where if you have a right triangle and across from the right triangle is what's called the hypotenuse, and that's our c. So a and b. So if you know a and b, okay, if you square it and square it, all right, and then take the square root of it, you get c. So what they're saying is, if you take the length of A, square it, the length of B, and square it, and then to get C by itself, you take the square root of A squared plus B squared. This equals the C. Okay? So that's how we can find C. Notice this. It is basically the same formula as this. That A is this information in here, and that B is that information in here. So what it's saying is, find the distance between these 2 points, find the distance between, let's say, this point, and then find the distance between this point and this point. They'll have your A, you'll have your B, and you can find out your C. Well, we just use a distance formula. So what we're going to do is a little bit of work here to see how it works. So we're going to find A is -2, -2, that's this point here. C is 3, +5, that's this point here. Okay? And then it says, then plot the points. Use the Pythagorean theorem to find the distance between A and B by drawing point B in. So they want B to be in, so we have 3, -2. So basically what they have then is they have a right triangle, if you look at it. Here, 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 and this is a right triangle. And they want to find the point from, if this is A, and this is C, and this is B, they want to find this distance here by using Pythagorean theorem. Now how are they going to do that? Here, let me clean this up, I'll show you. So they're going to, from A to B, straight line, from C to B, straight line. They want you to count the boxes. So from A to B, all right, we have 1, 2, 3, 4, 5, 6, 7. Okay, so that's a 7. And then from B to C, we have 1, 2, 3, 4, 5. So they have a triangle, okay, that's 7 on one side, 5 on the other, and they want you to find this missing piece here. So go back to the Pythagorean theorem. A squared plus B squared equals C squared. And what they want you to do is take this distance, put it in for A, take this distance, put it in for B, and find this distance, we'll call this C over here, C. So how do we find this all out? To get C by itself, we have to take the square root of it. So C equals the square root of 5 squared plus 7 squared. And if we use our calculator, 5 squared is 25. 7 squared is 49. Take the square root of that. So let's take that 25 plus 49. I think that's 74. The square root of that equals C. So turn your calculator on. Clear it. We're going to take the square root of 74. And we get 8.6. We'll leave it at that. Okay? So using the Pythagorean theorem, we drew a right triangle, and we found the missing side actually from A to C. So the distance from A to C is 8.6. But now what I'm going to do is show you how we can use the distance formula. Okay, so it's using the same thing. So what I want to do, all right, is let's see. I don't have a whole lot of room here. So what I'm going to do is I'm going to erase this stuff here. All right, give me some room here. So I'm going to use a different color. The distance equals the square root of x squared minus x1, x second point squared, plus y of the second point minus y of the first. So let's go back to point A and point C. Call it point 1, point 2, it doesn't matter. So we have the square root, x of the second point is -2, minus x of the first point is 3, square that, plus y of the second point, -2, minus y of the first point, 5, square that. So we get basically -5, use the parentheses, squared, plus -7 squared. And when we square this, we get 25. When we square this, we get 49. So basically, after we do all this work in here, we get the same thing as here. All right, the same thing as here. So we end up getting the same answer. So they're using two different formulas, the Pythagorean theorem, which we've done a little bit of, and now showing you that the distance formula works. Okay? So without using the Pythagorean theorem, let's just use the distance formula. Number 2, use the distance formula to find the distance between -3, 1. So that's -3, 1 right there. And then 4, 1. 4, 1. Now, if you're smart, always do this. Draw a line. And the reason why is this is a straight line. We can count the boxes. 1, 2, 3, 4, 5, 6, 7. The answer is 7. But if we call this point A and this point B, all right, or even better, let's call it point 1 and point 2. So point 1 is 4, 1. Point 2 is -3, 1. So that did the square root. Distance equals x of the second point minus x of the first squared plus y of the second point minus y of the first point squared, and we get -7 squared plus 0 squared. 0 squared is 0, so we get the square root of what's -7 squared? Put it in your calculator. -7 times -7 is 49. What's the square root of 49? Put it in your calculator. The distance equals 7. And that's the number of boxes we counted. So now what they're saying is you understand the Pythagorean theorem, and using the distance formula, we get the same answer. Now we're saying, hey, we got 2 points, one here and one here, and we can easily count the boxes straight across because there's a straight line on the coordinate plane, and we proved that it was 7 by counting, and then we proved it was 7 by the distance formula. So it shows that the distance formula works. Okay? I'm not going to practice 3 and 4. You can do that, but I'm going to use this piece here as practice. Okay? The distance D between the points x1, y1, and x2, y2 is as follows. And they give the same formula that we've seen. They want you to use that in these. It says label the x's, label the y's. Basically, I call 1.1 and 1.2. Use the distance formula. So the distance formula is D equals, I don't know why I put that in there. X of the second point minus x of the first squared plus y of the second minus y of the first squared. Then it says substitute. Let's put the numbers in. So x of the second point is 3 minus x of the first point, minus a negative 2 squared, plus y of the second point minus y of the first point squared. So we're going to need our calculator. Make sure you do your positive and negatives correct. So 3 minus a negative 2. So 3 minus a negative 2, I get 5. Plus 3 minus 5 is negative 2. 5 squared is 25. Negative 2 squared, do it on your calculator, is 4. So we get the square root of 29. And if we take that, clear everything off, we take the square root, 29, we get, I did it wrong, the square root, 29, I get 5.3851. If I want to round to the nearest tenth, there's the tenth place. Check to the right, is that 5 or above? Yep, so we add 1 here, so our answer is 5.4. Okay? Pretty simple. Now I'm going to come here. This is an interesting problem. So the triangle is if you notice A, B, C, the triangle, it's skewed, so you can't count the boxes. They're not equal. So I can't count from A to B. I can't count from A to C or C to B. But they want us to figure out if it's scalene, isosceles, or equilateral. Well, we're going to have to do 3 distance formulas, okay? 3 distance formulas. And what I want you to do, okay, I'll do 1. And then I'm going to want you to pause and do the other 2, okay? And then we'll get our answers, okay? So let's do from A, B. So A, B, this side. They want you to figure out the distance of that side. So call that point 1, call that point 2, okay? So what are we going to do? Let's see here. Let's do the distance formula equals x2 minus x1 squared plus y2 minus y1 squared. So the square root of x to the second point, which is 6, minus x of the first point, which is 4, quantity squared, plus y of the first point, or excuse me, the second point, minus y of the first point squared. So 6 minus 4 is 2 squared, plus 1 minus 6 is a negative 5 squared. You should recognize this work. 2 squared is 4. Negative 5 squared is negative 5 times negative 5, which is 25, which is a square root of 29. So again, I think we already did it one time. The square root of 29, I think we did right up here, is 5.4. So this distance, AB, is 5.4. Okay? What I want you to do is think about how to figure out AC and then figure out CB. Okay? You're going to do this 2 more times. You're going to do it once when you find AC. Okay, you can have this as 0.1 and this is 0.2, right? And then you're going to do it again as CB. Now I'm going to erase this work because when I do CB, I don't want this to be 0.2 and this to be 0.2. I will maybe call this 0.1 and the other one 0.2. So why don't you pause and try that? What I'm going to do is erase, okay? And I'm going to start again. So hopefully when you come back, you have your answers. I'm going to do BC first. So I have the square root. I'm going to call this 0.1, 0.2. All right? So the square root of x to the second point, which is 1, minus x to the first point, 6, quantity squared, plus y of the second point, which is 3, minus y of the first point, which is 1, squared. So 1 minus 6 is negative 5 squared plus 3 minus 1 is 2 squared, and that's the square root. So that's negative 5 times negative 5 is 25, plus 2 squared is 4, and that's the square root of 29, which we know is 5.4. So I have BC is 5.4, and AB is 5.4. So we're pretty good there, all right? So hopefully you can pause again as I erase, and you can come back, and then we'll do AC, okay? And we'll see how that works. And I use a different color there as well. All right, so for AC, I'll call this 0.1, A is 0.1, and C is 0.2. So I do my work again. So I have the square root. X of the second point is 1 minus x of the first point. 4 squared plus y of the second point, which is 3, minus y of the first point, which is 6 squared. So this becomes the square root of 1 minus 4 is 3 squared plus 3 minus negative 6 is negative 3 squared. 3 squared is 9 plus negative 3 squared is negative 3 times negative 3, which is 9, which is the square root of 18, okay? Using my calculator, because here's a new number, so we're going to do the square root of 18. I'm going to get 4.2426, round to the nearest tenth. Is that 5 or above? Nope. So that 2 stays the same, so this is 4.2. So I have 3 sides. 2 of them are the same. That means this is isosceles, okay? So that's kind of a different problem that you might see. Midpoint formula. Ugh. We got to figure out our midpoint formula. Now remember, midpoint is a point. I'm only going to do a few of these. So the first coordinate, the x. So let's remember, this first one that I'm doing is x, midpoint x. The second one, midpoint y. So I need an x and a y. So basically you take x1 plus x2 divided by 2. That gets you the x coordinate of the midpoint. And then you do y1 plus y2 divided by 2. That gets you the y value of the midpoint coordinate. So on here, let's do number 1. We have C is 6, 5. So 6, 5 would be right here. So that's C. And then 2, 1 is right here. Okay, that's D. And what they're saying is, if we drew a line from here to here, where would the midpoint be exactly? Well, let's take the x values. Let's do this. x1, call this 1, call this 2. So we have 6 plus 2 over 2, which is 8 over 2, which is 4. So there's the x coordinate. And then let's take the y, y1. All right, so that's 5 plus y2 is 1 over 2, which is 6 over 2, which is 3. So the new coordinate is 4, 3. 4, 3. 1, 2, 3, right there is where it should be, okay? So that's your midpoint, and you can practice the midpoints here, all right? I'm not going to do number 9 right now. You can practice these as well, but you also have a worksheet to work on, all right? Have a great